Hello, grade 8. How are you today? I hope you all are safe and well. Today our lesson about how can we write a word equation. We studied before about chemical reactions, and we studied how can we write the chemical reaction formula, and where can we put the reactants, and where can we how can we show the products. So today we will learn about how can we write it in words instead of symbols, okay, using symbols. Later we will learn about symbol equations. So now please open your books in page 136 and grab your highlighter. Follow me. Writing word equations. Word equations. You can use word equations to show reactions simply. This word equations show the combustion reaction of magnesium. They gave you an example of one of types of the reactions or sorts of the reactions, which is combustion reaction. We mentioned earlier about combustion reactions, and we said when we burn something or burning anything and to release heat or energy, this is combustion reaction. So we have here burning magnesium. When we burn magnesium in air, the oxygen atoms will join to the magnesium and form magnesium oxide. So we will write magnesium plus oxygen, then arrow to give us magnesium oxide. So what is this arrow, and what are these, and what is this? So first we have here the reactants. We should write the reactants on the left side of the arrow, and then we need to write we need to draw an arrow. Why we are drawing an arrow? This drawing, that means reaction is happening or reaction is taking place, chemical reaction is taking place. Then we need to write the products on the right of the arrow. So this is how can you write your word equation. So the word equation shows us two things: reactants and products. So the reactants, which is the starting materials, on the left where? Left of the arrow, this side. And products, what is made in the reaction, on the right of the arrow. The arrow means react to make, so this is important. If I ask you what the arrow in the reaction means, you will say react to make. In chemical equation, the reactants and products are different from each other. Why? Because they are because reactants are producing new substance. This is the product, a new chemical, new compound, different properties from the reactants. We cannot take it back. So the arrow in a chemical equation has a different meaning from the equal sign equal in the math equation. So we cannot write equal here because they are not equal. Magnesium is different from magnesium oxide, and oxygen is also different from magnesium oxide, because magnesium oxide is a compound, but these two are elements. The word equation below shows the combustion reaction of carbon in plenty of air to make carbon dioxide. Carbon plus oxygen give us carbon dioxide. Just react to make carbon dioxide. Okay, let's see the acid reactions. Combustion reactions are not the only type of reaction. There are many others. This reaction is about acid reactions. So we have acids with alkalis. When we react acid with alkalis, we will get salt and water. So here, Sam adds sodium hydroxide to hydrochloric acid. Sodium hydroxide is an alkali, hydrochloric acid is an acid. The alkali reacts with the acid, a neutralization reaction has happened. What is the neutralization means? Last year we studied about neutralization, and we said neutralization reaction is cancelling out acid using alkali or alkali by using an acid. So to make a neutral solution or neutral product. The products of the reaction are sodium chloride and water. This word equation shows the reaction. Hydrochloric acid plus sodium hydroxide react to make sodium chloride plus water. Sodium chloride is the salt you can add to food. The white salt that we are using for food, this is sodium chloride. Acid with metal oxides. Okay, so now we saw the acids with alkalis. So what about the acids with metal oxide? You can also neutralize acids with metal oxides. The equation shows an example. Sulfuric acid plus copper oxide. Copper oxide is oxide of copper, so we will get copper sulfate as salt, which is the blue material or blue substance, as crystals, and we can get water also. Copper sulfate is a salt, but it's not the salt in food. Actually, copper sulfate is very dangerous substance. If it's inhaled or digested at many quantities, this can lead to poisonous, vomiting, diarrhea, like poisoning of the body. And if it's inhaled, it can cause irritation for the lungs, and if it's splashed in the eyes, it can damage the eyes also. So we should be careful with using copper sulfate salt. Scientists say that a salt is a compound made when a metal replaces hydrogen in an acid. So here we have sulfuric acid and we have copper oxide. So copper sulfate plus water, then the copper replaced the hydrogen inside the acid and got copper with sulfur as copper sulfate, and the hydrogen to form water. Making salt. Maria uses the reaction in the equation above to make copper sulfate crystals. She writes down her plan. So this is her plan. When she wanted to make a reaction or to make a salt, this is like a small experiment. She needs to write her plan, what she's going to do exactly. So first she measures 25 cubic centimeter of sulfuric acid into a beaker. So we cannot use a beaker to measure the sulfuric acid. First we have to measure it in measuring cylinder, and then we have to pour it. Then we can pour it in a beaker, because beaker is the measuring cylinder is more accurate in measurements than the beaker. Add copper oxide powder, 1 spatula at a time, until no more reacts. This makes a solution of blue copper sulfate solution. It mixed with black copper oxide powder that has not reacted. Then she continued the third step, which is she needs to filter to separate the copper oxide powder. Then she wants to heat the copper sulfate solution over a water bath. Stop heating when half its water has evaporated. Leave the solution to stand for a few days. Copper sulfate crystals will form. Maria draws and labels the apparatus she needs for each stage. So here, first step, she wants to mix here dilute sulfuric acid with copper oxide powder, but when she measured 25 cubic centimeter with measuring cylinder, then she poured it in a beaker. Then she started to add copper oxide powder, 1 spatula at a time, because she needs to know how much copper oxide is needed to react with 25 cubic centimeter of sulfuric acid. Then she got a blue solution and copper oxide powder here at the bottom, not reacted. She took a filter paper here in the funnel. She poured the solution, she poured it inside this flask, and then she got copper sulfate solution, which is blue, okay? Then she need to take copper sulfate as a salt, which is crystals. So what she did, she took a beaker and she filled it with water to make it as a water bath. She placed the evaporating dish here with a copper sulfate solution, and then she started to heat gently until the half of the quantity has evaporated. She took it away from the fire or from the water bath, and she placed it in a warm place for a few days. When she came after a few days, she found copper sulfate crystals remains in the evaporating dish. So this is the picture of the copper sulfate crystals. She found crystals remained in the evaporating dish. Maria finds out about the hazards in her experiment. She asks her teacher how to reduce the risks from each hazard. This is so important in any experiment, in any project, and even small projects. We need to assess the hazards. We need to take care of the equipment, the temperatures, the fire, the glasswares that we are using So you need to write down the hazard and how to reduce the risk from this hazard. So first, she said copper oxide is harmful if swallowed. Dust irritates lungs and eyes. So how can she protect herself from this? First, she needs to wear eye protection by be careful when handling with spatula to prevent dust escaping. And then she wrote about copper sulfate. It's harmful if swallowed. Solid irritates eye and skin. So she needs to wear eye protection and do not touch with hands. She needs to wear gloves. Glass makes sharp pieces if broken. So she needs to place a glass apparatus where it cannot roll off table. Also, if it's she said the apparatus is hot because she's using fire here. So she should not touch until it cools down. So now let's go to the summary of the lesson. How can we write a word equation? A word equation, we need to write the reactants are on the left of the arrow, the products on the right of the arrows, and the arrow means react, make. So this was all about how to write a word equation. I hope you understood the lesson. Don't forget to write these notes in your notebooks, and don't forget the yellow box. I hope to see you soon safe, and I'll see you next time in a new lesson. Bye bye.